Hello everyone, welcome to the daily problem challenge discussion. Maximum distance to a closest person. Its index is 849 of the daily LeetCode problem. You can see the day is 16th of January and today we'll discuss the medium problem. Okay. So like the prerequisite required to solve such type of problems is yeah, you need to store the previous data, like you need to do some previous calculations, and then you are going to answer the maximum, like the you need to, in this problem you need to return the maximum distance to some closest person, and you're going to do this for every non-empty seat, and it is going to be done in O of one time, provided you have to do some pre-calculations. Okay, so like you need to have the efficient knowledge of how you are going to pre-compute the closest distance with respect to some a particular index. Okay, I will explain it out, all those you need not to worry about. So let's begin. You have been given some array consisting of row of seats where if the element seats of I is positive, it represents a person sitting on the ith seat, and if it is 0, it represents the ith seat is empty. Okay, and it is given that there is at least one empty seat and at least one person sitting. So Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized, and we have to return the maximum distance to the closest person. Okay, so let's understand how we can solve this problem. Let's pick up this example. Okay, so yeah, let me just erase this one. So you can see it is like 1 0 0, and again actually triple zero and 101 101. Okay, so you can see if the seats is 1, it means that it is being occupied, and if it is 0, it means that it is not occupied. Okay, so the person wants to sit over any of these positions. Let me first change the color. Yeah, so if it can sit over here, it can sit over here, and it can sit over here, also it can sit over here. Okay, suppose the person sits over here. So what is the distance from this person? So person would be like this one, distance from this person to the uh, closest non-empty seat. So you can say this is non-empty and this is the non-empty which is closest to this person. So you can see the distance from this is 3 and distance from this is 1. Okay, so you can see the closest non-empty seat is coming out to be 1. Okay, so if the person is going to sit over here, so the distance between him and the non-empty seat closest to him would be 1. Okay, and actually you need to maximize the distance between the person and the closest non-empty seat. Okay, so if the person sits, the answer comes out to be 1 over here. Okay, so let me write down everywhere that if the person sits over here, answer comes out to be 1. Okay, what about if the person sits over here? If the person sits over here, you can see here it is distance is actually 2 and here it is distance actually 2. Okay, so you can see if the person sits over here, answer comes out to be 2, like the distance between him and the non-empty seat. And if the person sits over here, you can see the distance comes out to be 3 and distance comes out to be 1, but you need to find out the closest non-empty seat. So you can see it is coming out to be 1. So if the person sits over here, answer is coming out to be 1, and the person cannot sit over here because this is already occupied. And what about if the person sits over here? So distance is 1 and distance is 1, so answer comes out to be 1. So you need to return the maximum element. You can see 2 is the maximum element, so your answer comes out to be 2. You can see this is the 2. So if Alex sits in any other open seat, the closest person has distance 1, thus the maximum distance comes from the 2. You can see the Alex is going to sit over here. Okay, so there are many different cases also. This was the very much simplest one. So let me take some another case like 0 0 0 0 0 1 1 1 1 1. Okay, now you can see that you have some consecutive segments of empty seats and there is a person occupied over here. Okay, now Alex comes and Alex have to sit on any of the, you can see non-occupied seat. So if Alex sits over here, the distance comes out to be 1. So if the Alex sits over here, distance comes out to be 2. So you can see the distance are increasing as we move from right to left, okay, over this consecutive segment of 0. So the most optimal case is to Alex is to sit over here. Okay, so in that case the distance comes out to be 1, I don't know, 1 2 3 4 5. So in that case our answer comes out to be 5. Okay, so how we are going to solve this problem efficiently? So you can see whenever some consecutive segments of zeros is going to occur at the beginning of this array or at the end of this array, like this one. You can see it is at the end of this array. So whenever the consecutive segments of empty seats occur in the beginning of this array or at the end of this array, so what you need to do is you need to pick up the closest point, that is the if it occurs at the beginning of this array, you need to find the minimum index where the non-empty seat is occurring, and just you need to find out this distance. Okay, and what about when it is occurring at the end of this array, like consecutive empty seats? In that case you need to just find out the number of empty seats, or you can also say the maximum index where the non-empty seat is occurring, which is this one, and you need to find out the distance if the person sits over here with respect to this distance. Okay, so that was the case, and there are one more case also, that is between two non-empty seats. Like suppose this is the seats and we have some zeros, okay, and we have some seats again. Like you can see in that case the this is actually the empty seats. So a person has to sit at that position which maximizes the distance with respect to the closest person. So you have to sit in the median of this consecutive segment of zeros. So it means that you are going to sit over here. So here the distance comes out to be 3 and here the distance comes out to be 2. So you have to take the minimum, which is comes out to be 2. Okay, so there is one more generalized approach also. So you can see if there occur 3 consecutive zeros and there is someone over here and there is someone over here, so you can see it is 3. So your answer would be like 3 plus 1 upon 2. That is the ceiling value of this 3. You can see which is our 2, which is our current answer. So if the person sits over here, that is if the person sits over here, you can see distance comes out to be 2 and distance comes out to be 2. What about if there exist 4 consecutive zeros and between those two zeros there exist ones? So you can see, let's say there exist L amount of zeros over here, so your answer would be again ceiling value of L, which is comes out to be 2 again, because if you sit over here there exist 3 distances, sorry, there would be exactly 2 distance, and if you sit over here there would be exactly 3 distance, but you have to take the minimum distance to the with the respect to closest non-empty seat. Your answer comes out to be 2. So this is the maximum distance. So whenever there exists some consecutive segment of zeros and those segment of zeros is bounded by some non-empty seat, you have to find out the ceiling value, right? And what will happen if those consecutive segment of zeros is not bounded by the non-empty seats right over here? It means that it is always occurring at the beginning of this array, like this one, you can see, or it is occurring at this end of this array, like this one. You can see this is occurring at the, in that case you need to just do nothing, just pick out this length of this segment, which will be your answer, because the person will always be sitting at the extreme position, like at this one or at this one. So the question so the problem boils down to the very simple case. So let's look out the code and how this can be efficiently done. Okay, so I need to just go for the submissions. Yeah, I have some you can see this segments like consecutive segment of zeros. This can be implemented in O of n time and O of 1 space, but I have some extra solution also which uses the O of n time and O of 1 space. You can see, sorry, O of n space, but that is quite lengthy, so I will try to explain this one. So you can see the consecutive segment of zeros, if it can occur at the beginning of this array or at the end of this array. So what will happen if it occurs at the beginning of this array? So I will first find out the least index where the non-empty seat is going to occur, first non-empty seat is going to occur, let the index be I. So our answer is going to be initialized with I, because the person will always sit at the 0th index, and the distance from this person to the closest non-empty seat to the right of it will be always I. And let's initialize count as 1. So I will just pick out the always the consecutive segment of non-empty seat. Okay, sorry, consecutive segment of empty seat that is filled with 0. Okay, so first I will pick out all those consecutive segments having the same value, and if the segments is of 0, means we have found out the what empty seats. You can see seats of j minus 1, that is the segment is of filled with 0. Then you need to just do the ceiling value as I've already said, and just initialize count as 1, because we need to find another segments having the same type of numbers. So if the final value you can see is a non-zero value, sorry, if the final value is 0, you can see seats dot back is exactly 0, it means that it is an empty seat. In that case you need to take the length as I've already said. So you need to maximize your answer with the count and finally return the answer. In that case you will get all the test cases passed. So if you guys have any doubts, do let me know in the comment section of the video, and thank you for watching this video.